doesn't sound too good. Okay, so we're going to look at trig equations here from exam questions. The first one here, it says determine the general solution for cos 2x plus 4 sine squared x minus 5 sine x plus 1 equals 0. Well, one, which you actually have, you've got sine squared x, you've got sine x, and you've got a number. You're actually looking about creating a trinomial. You've got cos 2x here, and you've got three options to choose from to pick cos 2x to try and find the one that's going to work for you. Well, you pick the one that puts it just into sine squared. So cos 2x is 1 minus 2 sine squared x. Well, that's going to do it for you because 4 sine squared minus 2 sine squared, that's just 2 sine squared x. Those are like terms. You can put them together. You've got a minus 5 sine x, and you've got 1 plus 1 equals 2. Then you put down two brackets, and we're going to factor this trinomial. You put 2 sine x times sine x. That's how you get 2 sine squared x. Now, the only way to get 2 is 1 times 2. But if you've got a negative here and a positive here, it must be 2 minuses. But you're looking for 5 somehow. So 2 times 2 will give you 4x. And 1 times sine x gives you another 1x. It's negative minus 4x minus 1x. That gives you the minus 5x. Now you've got 2 sine x minus 1 equals 0. You've got sine x minus 2 equals 0. So sine x equals 2, but your calculator says error, so there's no solution there. But here your calculator says 30 degrees and 150 degrees. 30 degrees works, and we know that 180 minus 30, or 150, is the other solution. And this is your general solution for this, this equation here. Now, the next one is really just basically the same thing. This question here, you multiply everything by cos, you get cos squared minus 5 cos x. It cancels here, you get a 4, subtract 4, you factor it, you let both things equal 0. And here it's cos x equals minus a half. You subtract 1, divide by 2, shift cosine of minus a half is 120 degrees. Plus or minus 120 degrees are your two answers for cosine. And it repeats itself every 360. Shift cosine of 4 over 3, there is no solution here. Your calculator will say no solution. Let's take a look at one that's a little bit trickier in a way. This cosine 2x here, and you've got a cosine and a sine x. Well, you might, this one has cos x and sine x. I'll just show you, this is the way that that works, but it might take a little while to figure it out. Cos 2x is really cos squared minus sine squared, cos squared x minus sine squared. That'll give you 2 cos squared x minus the sine x cos x. I'm going to bring it over on this side. Minus sine squared equals 0. Now I set these, make two brackets. 2 cos x times cos x is your 2 cos squared. Sine x times sine x is minus sine squared x, plus and minus. Now, if I put a minus here, I'll get minus 2 sine cos x, and a plus 1 here, plus 1 sine cos x. Hey, that works out. I set both of these things equal to 0, and then there's a special trick. There's a special trick here. I move the 2 cosine x over on this side. I move the cosine x over here. I minus cos x from both sides. But this time I divide by cos x. What do I get? Sine over cos equals the tangent of x. And a good trick, because I go shift cosine of minus 2, and it tells me negative 63.43 plus k times 180. Here I divide by minus cosine. I get cosine x equals 1. Shift cos tan of 1 is 45 degrees, and it repeats every 180 degrees. So that's a special trick here. When you have sine and cos on both sides, you can divide by cos to create tan x, and then you can find the general solution. That's a special trick. It comes up quite a bit, but I'll just leave it there. Okay.